Welcome to video 2 for this unit on functions. In this video, we're going to focus on interpreting function notation. What does a statement like p of 3 equals 12 mean? On its own, p of 3 equals 12 only tells us that when p takes 3 as its input, its output is 12. If we know what quantities the input and output represent, however, we can learn much more about the situation that the function represents. If function p gives the perimeter of a square whose side length is x and both measurements are in inches, then we can interpret p of 3 equals 12 to mean a square whose side length is 3 inches has a perimeter of 12 inches. We can also interpret statements like p of x equals 32 to mean a square with side length x has a perimeter of 32 inches, which then allows us to reason that x must be 8 inches and to write p of 8 equals 32. A graph of a function can likewise help us interpret statements in function notation. Function f gives the depth in inches of water in a tub as a function of time, t, in minutes, since the tub started being drained. Here is a graph of f. Each point on the graph has the coordinates t, f of t, where the first value is the input of the function. The second value, f of t, is the output. F of 2 represents the depth of water 2 minutes after the tub started being drained. The graph passes through the point 2, 5, so the depth of water is 5 inches when t equals 2. The equation f of 2 equals 5 captures this information. F of 0 gives the depth of the water when the draining began, when t equals 0. The graph shows the depth of water to be 6 inches at that time, so we can write f of 0 equals 6. F of t equals 3 tells us that t minutes after the tub started draining, the depth of the water is 3 inches. The graph shows that this happens when t equals 6. Some functions are defined by rules that specify how to compute the output from the input. These rules can be in words or in function notation. For example, a rule in words is to get the output of function f, add 2 to the input, then multiply the result by 5. The same rule in function notation is f of x equals the quantity x plus 2 times 5, or 5 times the quantity x plus 2. Another example of a rule in words is to get the output of function m, multiply the input by 1/2, and subtract the result from 3. This rule in function notation is m of x equals 3 minus 1/2 x. Knowing the rule that defines a function can be very useful. It can help us to find the output when we know the input. If the rule f of x equals 5 times the quantity x plus 2 defines f, we can find f of 100 by evaluating 5 times the quantity 100 plus 2. A function rule can also be used to create a table of values. Here is a table representing function f. A function rule helps us to graph the function. Here is a graph representing function f. For function f, the values of f of x are the vertical values, which are often labeled y, so we can write y equals f of x. Because f of x is defined by the expression 5 times the quantity x plus 2, we can graph y equals 5 times the quantity x plus 2. A function rule also helps us to find the input when we know the output. Suppose the output of function f is 65 at some value of x, or f of x equals 65, and we want to find out what the value is. Because f of x is equal to 5 times the quantity x plus 2, we can write 5 times the quantity x plus 2 equals 65 and solve for x. Therefore, f of 11 is equal to 65. The function f is an example of a linear function. A linear function is a function that has a constant rate of change and its graph is a line. Thank you for watching video 2 of 7 for this unit on functions.